안녕하세요 여러분, 한경갑니다. My name is Mehmet Hilmi Emel. I work as an MLOps engineer at Acedemand. And this is our session plan. I actually wrote 45 minutes, but it's going to be 1 hour. So we can skip this slide. Okay, this is our session title. And as we can see, this title highlights two main concepts. The first one is MCP servers, and the other one is AI agents. So if you want to understand MCP servers better, we need to know AI agents. And to deeply understand AI agents, we need to know their evolution process. So I will begin this session by reviewing that evolution. Okay. Initially, we had only LLMs, and LLM stands for large language models, and these models are defined as an AI model designed to predict next words. So this is basically a text generation model, and when we put predicted words together, it makes meaningful sentences. So these models were widely known in 2022 when OpenAI released their product, ChatGPT. And of course, everybody knows ChatGPT. This product could understand and respond like humans, and it was powered by an LLM model, GPT-3. While earlier models existed like GPT-2 or Google BERT, GPT-3 was the first model that achieved successful results. However, even though these models could understand and respond like humans, we observed that they sometimes provided inconsistent and false information, and we call it hallucination problem. So to address this hallucination problem, we adopted a new technique called prompt engineering, and by using specific prompt templates, we observed an increase in the LLM's answers. But these LLMs have still two main limitations, and the first one is knowledge cutoff problem, and the other one is data limitation problem. So what is knowledge cutoff? If I should give an example, if a model was trained on 2024, it has no knowledge of events that happened in 2025. So it is basically a knowledge cutoff problem. And we have data limitation problem. For example, when we ask a question, when we ask our private question to LLMs, they cannot provide correct answers because they haven't seen our private data during training time. So to overcome these issues, the new concept was introduced, and it was RAG. RAG stands for Retrieval Augmented Generation, and it works by finding the vector similarities between users' requests and our external sources. And our external sources might be private storage, and it might be internet. And RAG systems can retrieve the most relevant information from these external sources, and then LLM use this information to generate final answer. So this is how basically RAG system works. And since RAG system can access current information from internet, it solves knowledge cutoff problem. And since RAG system can achieve our private storage, it solves data limitation problem. Then we start to ask this question: what if our system could perform an action rather than just retrieving data? For example, a user might search the most suitable hotel reservation in specific dates, and our RAG system can access the information from internet, and it retrieves the most suitable hotel for the user. But if we add tools that allows the system to complete actual reservation process, it makes our system much more powerful. And if we add more tools, and in this system, LLM acts as a brain of the system, and it decides which tools is going to be used for user's request, and we have RAG system to reach external sources. Actually, we lay foundation for AI agent. So this is a basic AI agent. And we have multiple agent systems. A multiple agent system is a system where multiple agents can communicate, exchange information between each other, and each agent has their own tools, their own models, and their own rack system. And for instance, when a user asks a question to our system, if an agent doesn't know the answer for user's question, it can transfer the conversation to other agents, and the other agents can generate answer for the user. So this is how multi-agent system works. Okay. To summarize, what is AI agent? We have end user, and when our end user asks a question to our agent runs in agent runtime. And in agent runtime, we have three components: generative AI models, orchestration component, and tools component. In previous slides, I always talk about LLMs, but it doesn't have to be LLM, because today we have multi-models that takes various data types as an input, so it doesn't have to be an LLM. And in orchestration component, we assign profile, goals, and instructions to our agents, so our agent system can know what to do. And we have memory part. Memory stores conversation history between user and agent, and when our agent needs to access past information in conversation history, it can take the information and generate final context-aware responses. And we have reasoning and planning, and this part decides which tools is going to be used. And in tool component, we can define APIs, function, databases, or other agents tool as a tool. And our agent runtime will generate the final answer, and it will send to the end user. So it is how an agent system, agent runtime works. And we can see an example of mail agent. For example, I decided to use Gemini model for GenAI orchestration, and GenAI component, and for orchestration component, I define description and instructions, and for tools component, I decide to define 6 tools like search emails, send email, read email, download attachment, modify email, and delete email. For instance, when a user sends request to our agent system, like send email to person A, my mail agent takes this request as an input, and Gemini model decides like, okay, I have 6 tools, and the most appropriate tool is send email because user wants to send mail to person A. So this is how an agent works. Okay. Everything is great, but what about multi-agent systems? And in this slide, we can see an example of multi-agent systems. And this system has 6 agents, like agent A, B, C, D, E, and F. And agent A has 3 tools, agent C has only 1 tool. And agent A can communicate with agent B, C, and D, and agent D can exchange information with agent E and F. But if you look at this multi-agent AI system, actually there is a problem. And the problem is agent B. Because agent B has 10 tools, and defining these 10 tools might bring some challenges for developers who are going to build this multi-agent system. And this is the reaction of my developer. So some challenges, like it can cause long and time-consuming development process, because defining these 10 tools makes the development time longer. And other challenge is repeatedly rebuilding tools that do the same thing. For example, we are working in one project and we define tool for that project, but at the same time, we are working in another project too. So let's say I define tool for first project and I need to use the same tool, but I have to define it in my another project. So, I mean, repeatedly rebuilding tools that do the same thing makes also development process longer. And we have different frameworks to develop AI agents, and for tool definitions in different frameworks might be challenge for our developer. So is there any way to standardize between my agent and tool? Is there any solution for my problem? And my solution is MCP. So the developer is happy right now because he found MCP. MCP stands for Model Context Protocol, and it was developed by company Anthropic. And in their official web page, they describe MCP like, just as USB-C provides a standardized way to connect electronic devices, MCP provides a standardized way to connect AI applications to external systems. So since we can define tool to reach external sources, we can create an MCP server, and we can host our tools, prompts, and resources. And by following MCP, our agent system can access tools inside our MCP server. And this is the new form of our multi-agent systems. And right now, we only define MCP client inside our agent B. And we are using an MCP server that might be developed by other people. And yeah, we just need to define MCP client, and by following MCP, I can access the 10 tools. So it makes development time shorter. But we still have problems, and the problems in red rectangle area. Actually, we have the same problems like we had in tools definition. For example, defining these agents might make the development time longer because, let's say, we want to build multi-agent system and it has 50 agents. So defining these 50 agents can increase development time. And let's say a tech company developed their agent and it is really good and comprehensive, and I want to get benefit from that agent. I don't want to try to write the agent's capabilities by myself because they say I don't have enough experience for it. So is there any way to connect with that remote agent? And yeah, there is a solution for it, and it is A2A. And A2A stands for agent to agent, and it was developed by Google. And if you look at this image, we have client agents and we have remote agents. So if we want to get connected with remote agents, we can follow A2A protocol and we can get benefit from that remote agents. And remote agents send agent card to our client agent. So my client agent can have an idea about my remote agent's capabilities. In this tutorial, we will see how remote agents send agent card to client agents. We will see an example of agent cards. Okay, and A2A and MCP protocols are complementary protocols. They are friends. And by using these two protocols, we can make our multi-agent systems much more powerful and much more better. So these protocols are really helpful for developers. And yes, tutorial time. In this tutorial, we will use FastMCP to create an MCP server and Google ADK, Google Agent Development Kit, to create AI agent and server agents. And I haven't mentioned Agent Gateway in my session title because I wrote a call for paper for this event 4 months ago. But 2 months ago, I joined Open Source Summit Europe, and the Agent Gateway was introduced in keynote sessions. And I just wanted to include this product to my tutorial because it is an open source project that is built on AI native protocols to connect, secure, and observe agent-to-agent and agent-to-tool communication across any agent framework and environment. So since we will create an AI agent and MCP server to observe agent-to-tool communication, I can use this product and I can secure, I can make MCP authorization. And since we are going to create client agent and server agent, when I want to observe agent-to-agent communication, I can use this agent gateway. And in this example, we will define a country agent, and it will have 4 tools like get weather forecast, get public holidays, get country info, and get current date. And I found some free APIs, and in these tools are calling some free APIs, so you can use these tools by yourself. Okay, and we will define an exchange agent. It will have 2 tools like get exchange rate and get current date. And our exchange agent will be sub-agent of country agent. And when user asks a question about a country's currency, our country agent will transfer conversation to exchange agent, and my exchange agent will respond for user's question. And after that, we will create an MCP server, and we will carry our tools inside that server. But as I mentioned, to secure or to observe agent-tool communication, I will put agent gateway between my agent and MCP server. And in next step, I will make this system as a server agent, and I will create a client agent. It will have travel agent, and I will make connection between my client agent and server agent by following A2A protocol. And to observe agent-to-agent, I will use agent gateway. And yeah, I wrote a PDF file for this tutorial. You can find whole steps, step-by-step guideline for this tutorial. You can access it just by scanning the QR code. Okay, and yeah, I will try my best. 들어주셔서 감사합니다. And right now we will work on Visual Studio. I will open my Visual Studio, and let me. Okay. So inside my project, I created 2 folders. The first one is my client agent, and the other one is my server agent. So inside my server agent, as I mentioned, we will create country agent. Maybe let me zoom in. We will create a country agent and exchange agent, and we will define some tools. So inside my server agent, I created a file named agent file. And to create an agent, to create an AI agent, I import agent class from Google ADK agents. And in this file, first I create a variable named country agent, and this variable, this agent class takes some parameters like name and models, and I assigned my country agent to root agent. Because Google ADK is looking for root agent variable, if I try to run my project, if Google ADK doesn't see a root agent variable, it will give an error. So we can try it. Let me comment this line. Where is my terminal? Okay. And to run my project, I will run ADK web. And this command gives me an UI chatbot to test my agents, and it gives me an URL. When I click this URL, I can see that this UI chatbot UI that's provided by Google ADK. Let me zoom in. And inside, it says select an agent, and I will select server agent. And I will try to write hi, but it will give an error because, as I mentioned, I have to define I have to create a root agent variable. So to do this, I will delete this, okay? And yeah, if I rerun my project right now, my agent will start, my project will start. Okay. Let me refresh the page, and I will type hi. And yeah, I can get answer from my Gemini model because I'm using Gemini model. And if I click this country agent icon, I can see the architecture of my agent system. And I want to ask a question to my agent like, what is your capabilities? And it will give me answer. But the answer is like, as a large language model, I have wide range of capabilities, including text generation, translation, reasoning, and problem solving. But this is not the answer that I want, because I want to create a country agent, and I want to customize my agent. To do this, inside my agent class, I will add description and instruction parameters. And as a description, I wrote an agent that provides information about the country. And for instruction, I created a new file named instructions file. And I created country agent instruction variable because I didn't want to define it inside my agent file, because generally instructions are really long and I don't want to put it in my agent file. And instructions is really important because you tell about how your agent system will work. So, for example, I wrote, you are the primary AI country agent. You have access to 4 internal tools like get country info, get weather forecast, get public holidays, and get current date. And in the end of this sentence, it says, you can also redirect currency-related queries to a specialized exchange agent. So, and inside my instruction file, I wrote an execution logic. I say, okay, in first step, you need to make a classification. If users ask a question about currency or exchange rates, go to dedicated exchange agent, but else follow the next steps. So if you want to make your multi-agent system or agent system, you need to write detailed instructions. It is really important. And I will import this variable to my agent file. To do this, I add this line, and yeah, I assign country agent instruction to my instruction parameter inside agent class. So let me rerun my project, and I will ask the same question. Okay. And right now, it will give an answer like, I am the primary AI country agent designed to provide you with information about countries. Here's what I can do. And yeah, the answer is, this is the answer that I want. And I will try to ask this question, can you give me information about South Korea? And when I ask this question, it tries to call this get country info, but we didn't define any tools inside our agent. So the next step is defining the tools. To do this, I created a new file named tools, and inside this file, I wrote some functions. And for example, get country info function takes country name as a parameter, as a string, and we need this country name, and we convert it to encoded country name. And we are using this encoded country name to call this URL, and after we call it, we have a response. Inside this response, we are retrieving the relevant information, and we return JSON object. And we have other tools like get weather forecast. It takes latitude, longitude, and model parameters. We need these parameters to call this free API. And after we call this API, we have a response. I selected the information that I want from that response and return JSON output. We have get public holidays. It needs year and country code, and we call this URL the same steps. And to get current dates, I just call the time library. And we need this tool to use in our Exchange agent. We won't use it inside our counter agent. Okay, inside our agent file, I will import my tools. So, yeah, and I will, let me delete this, okay. And right now, I will import my tools inside tools parameter. If I save my file and rerun my project, let me copy this question and page it, refresh the page. Okay. Right now, my agent calls getCountryInfo tool, and it generates the final answer. If I want to see my agent architecture, I can click this icon, and as we can see, counter agent has it can access 4 tools like get country info, get public holidays, get weather forecast, and get current date. And I can see that my agent tries to call get country info tool, and it gives South Korea as an argument for my country name parameter inside this function. And we can see an example like, okay, here is the information about South Korea, country name South Korea, capital Seoul, and you can see the Korean flag. Okay, and let me ask another questions like, what is the weather forecast for Korea? And right now, my agent will call get weather forecast. It will use model, latitude, and longitude parameters, and it tries to call this tool. And we have a response in JSON format, and our country agent retrieves this JSON object and generates this final answer. And last question, what is the public holidays of South Korea? And my agent firstly calls this get current dates because get public holidays needs the year parameter, and we can, my country agent decided to use get current date to provide this information. And yeah, we can see the response of get current date tool. And after that, country agent decided to use this information to call get public holidays tool. And we can see the get public holidays in South Korea for 2025. But if I write something like in 2024, right now it won't call the get current date tool because I specified the year inside my request. And when the country agent tries to call get public holidays tool, it gives 2024 as an argument. So, okay, my tools are working perfectly. And right now, I will create an Exchange agent. And to do this, I will go to my agent file. And let me comment out. Okay, I've created a variable named Exchange agent. And it has an agent class. Inside this agent class, I defined name, model, description, and instruction parameters. So I did the same steps same steps with country agents. So And I define tools. So as we can see, we have get exchange rate tool, and I can import it inside my exchange agent, so my exchange agent can use these tools. And to communicate with, to binding my exchange agent to country agent, I have to give sub-agents parameter inside my agent class, and I define exchange agent as a sub-agent of my country agent. So let me save this file, and I want to rerun my project. And let's say I want to ask a question like, what is $1 in Korean won? When I ask this question, my country agent doesn't know how to answer this question, and it transfers to exchange agent. And right now, exchange agent is using get current date firstly, because my get exchange rate tool needs currency date parameter. So it calls get current date, and it retrieves an response from my tool, and then it uses this tool to answer my question. And it says on 2025-11-5, the exchange rate was $1 equals to 1,439 Korean won. And okay, so my agents are working, but the next step is creating an MCP server. We will query our tools to our MCP server. To do this, I created a new file named my MCP server, and inside my FastMCP library, I've imported FastMCP class, and in the end of this file, I wrote MCP, I called run method, and I said it's going to be run on port 8001, and it's going to use streamable HTTP connection. And the rest of the code actually is simple, because I just copied my tools file and pasted inside my MCP server file. But I also add this decorator, because if you don't use this decorator, it won't serve, this get country info will not be served as a tool. So if I want to host get country info as a tool, I have to use this MCP tool decorator. Okay, so right now I will create my MCP server, and I will run this command, Python my MCP server. When I run this command, we can see that it gives an URL. It runs on port 8001, localhost 8001, and I can access my tools inside this MCP server. So I will go to my agent file, and right now I will comment these lines, because I won't use these tools from my tools file, because I have an MCP server. And let me comment them. And okay, I imported MCP toolset and streamable HTTP connection params class from Google ADK Tools MCP tool. And as you can see, I give my localhost 8001 URL for my MCP server. So actually, I define an MCP client, and my agent can access the tools by using this URL. So I will change my tools parameter inside agents, and I will save my page. Let me rerun the project. And I want to ask the same question: what is $1 in Korean won? And yeah, my agent can access the tools inside MCP server, and it can give the answer, like it can give the same answer. But if you look at the agents architecture, actually we have a problem. Right now, my two agents can access 5 tools, whole tools in my MCP server, but I don't want my exchange agent to access like get country info tool, because it should only access get current date and get exchange rate tools. But when I define an MCP server, these two agents these two agents goes to the same MCP server, so they have access to the same tools. So to solve this problem, we are going to use agent gateway, as I mentioned in my slide. And agent gateway will listen 2 ports. First one is 3000 and the other one is 3001. My counter agent will send request from port 3000, and agent gateway, I define a counter agent route as a route, and agent gateway will direct request to my backends, my MCP backends that runs on localhost 8001. And this is the important part, because I want my counter agent can access to 4 tools like get country info, get weather forecast, get public holidays, and get current date. So it is really important line. And for 3001, I did the same thing. I defined exchange agent route. It will direct request from 3001 to my MCP server. But I also define MCP authorization, and my exchange agent should access only get exchange rate and get current date tools. Okay, so to apply agent gateway, I need to run a command, and this command is agent gateway and my file name agent gateway config YAML. So when I run this command, yeah, actually I set agent gateway, and agent gateway gives me an URL that runs on localhost 15,000. Let me zoom in. And yeah, we can see our listeners like port 3000 and 3001. We can see our routes like counter agent route and exchange agent route. And yeah, we can have MCP backends that runs on localhost 8001. And we can go to policies section, and for example, for port 3000, my agent can access only these tools. I can see the MCP authorization expressions inside my agent gateway UI. And my favorite part is playground section, because before binding my MCP server to my agent, I can test this MCP server. So let me click connect button, and yeah, my counter agent will access 4 tools, and let's say I want to test this tool inside the MCP server, and let me write South Korea, and it gives me a response, and we can see that country name South Korea, capital Seoul, population 52 million. And let's say I want to try this get current date, and yeah, we can access the today's date. And okay, so right now I will put my agent gateway inside my agent file, because as I mentioned, we have this kind of agent architecture and it's not secure. So to do this, let me comment these lines. And okay, right now I defined 2 parameters named country agent toolset and exchange agent toolset. They will go to, for example, country agent tool go to localhost 3000, because my agent gateway listens from that port, and exchange agent goes to 3001. And right now in my tools definition, I will comment these parts. And let me, okay. And let me save my file. And let me refresh my, let me rerun my project. I will copy this question and I will ask again. And it will give me the answer. And if I look at my architecture right now, as we can see, country agent has access to 4 tools: get current date, get country info, get weather forecast, and get public holidays. And it has exchange agent as a sub-agent, and my exchange agent can access 2 tools. Okay, and right now we will create a server agent by using A2A protocol. But actually, creating a server agent is really simple by using Google ADK. So, okay, I am inside my agent file, and to create a server agent, I will import this function to A2A from Google ADK A2A utils agent to A2A. And I will create a new variable named country agent server, and I will use this function, and I will give my root agent as a base agent inside my function. And let me save my file. And to create agent server, I will run this command. Okay, unicorn server agent, agent country agent server, port 8002. So it is looking for my country agent. Oops, sorry. Country agent variable inside my agent file under my server agent folder. So when I run this command, yeah, it gives me an URL, and my agent server runs on this URL. If I click this, and as I mentioned, server agent sends agent card to client agent, so my client agent can have idea about remote agent's capabilities. So to see the agent card, I can enter this path, and yeah, we can see our server agent's capabilities. For example, its name is country agent, and its description is an agent that provides information about the country, and which is the same like we define in this line. And we can see our instructions, we can see our tools like get country info, get weather forecast, get public holidays, or I can also see my sub-agents, exchange agents, and I can see its tools. Okay. So right now, I created a new folder named client agents. But before that, I can also use agent gateway to observe agent-to-agent communication. And to do this, I will add these lines. My agent gateway will listen port 3002 to observe agent-to-agent communication, and it will direct to backend on localhost 8002. Let me save my file. And if I go to Agent Gateway dashboard, and if I refresh my page, I can see that Agent Gateway listens 3 ports, and it is the 3002 is for my server agent. And I can also test my server agent before binding it to my client agent. To do this, I will click Connect button, and yeah, I will see my country agents and its available skills. Actually, Agent Gateway retrieves this information from this agent card, and it provides an UI. And for example, I want to try this model. I want to try my whole model. So to do this, I will ask question like, what is $1 in Korean won? And I will click Send Task button. And yeah, as we can see, our server agent can answer to my question. And yeah, I've created a new folder named client agent, and inside this client agent, I created a file named agent file, and I described an agent named travel agent. I defined descriptions and instructions for it. But for this tutorial, I define small instruction, and it maybe it can give some errors, but I hope it won't give. And yes, to access my agent, server agent, I will import this class from remote A2A agent. And inside this class, I gave name and agent card parameter. So yeah, this remote A2A agent class needs agent card, and it is mandatory parameter. And I define sub-agents inside my travel agent, and I gave this variable to my sub-agents field. And let me run this project again. ADK web. Let me refresh the page. Okay, right now I will click client agent because I want to test my client agent. And let me write hi. So if I want to see my architecture, travel agent can communicate with country agent, but we can see its tools because I don't know why, but Google ADK doesn't support to see server agent tools. But we can test these tools by asking some questions, and right now I will ask these questions. For example, and by the way, this is the PDF file that I wrote. And here, okay. What is the flag of South Korea? I want to ask this question. And my travel agent doesn't know how to answer this question, and it transfers conversation to country agent. And my country agent answers this question like South Korea's capital is Seoul, and its population is 52 million. And inside this event, I can see that my country agent calls get country info, and it gives South Korea as an argument for that function. So we can observe that my country agent is using this tool. And I want to ask these questions too. Yeah, this is the problem because, as I mentioned, I haven't written detailed instruction. And let me write use country agent to answer this question. Right now, it will transfer conversation to country agent, and it will give weather predictions for South Korea. And yeah, there is an answer. And let me try these questions too. Okay. And we can see the public holidays in South Korea. Okay, and finally, I will ask this question. Yes. Okay, so as we can see, we create a client agent and server agent, and we use A2A protocol to get connected with my remote agents. So, and my client agent, my travel agent can access the country agent, and it can access its capabilities, so its tools. So actually, I finished my tutorial. I hope it was helpful and beneficial presentation. I hope you liked my presentation. So thank you so much for listening to me.